In this video, we are going to cover solving linear substitutions or linear systems, and we're going to use a method called substitution. Let's go through the steps. So first of all, when we're going to choose substitution is when equations are not ready to graph. We've already practiced graphing systems of equations with graphing. Also, you might graph and have those two lines intersect on when it's not an integer, which is not a corner. And ideally, when we use substitution, one variable is solved for or all by itself, so we can plug that chunk in. The steps then for substitution are, again, to take that first value that you know and plug it into the second equation. And everything then should be in terms of one variable. You should only see all x's or all y's once you substitute in the first time. You then will solve for the first variable. And once you get that first answer, like x equals 6 or y equals 5, you would take it and plug it back into the first equation when the variable was by itself. And of course, we should, when we're dealing with systems of equations, check our solution by plugging x and y back into both equations. So let's go through a few examples here, practicing this process. So this is a situation where maybe we don't have graph paper, we're not ready to graph, but I notice that in this equation we have x by itself. And so we can take what x equals, which is negative 3y minus 2. And I like to plug that into parentheses. I don't put the x in parentheses, but I put the chunk that I want to plug in parentheses. And then I'm going to put x in parentheses in the second equation because I want to take this and I want to plug it in. I want to replace down here in this chunk. So let's rewrite that bottom equation as negative 4 times the quantity, negative 3y minus 2 minus 5y equals 8. And to solve this then, notice this is all y's, and so we can distribute. Negative 4 times negative 3 is positive 12y. Negative 4 times negative 2 is positive 8. Minus 5y equals 8. And combining like terms, I notice that I have a 12y and a negative 5y. That's going to make 7y plus 8 equals 8. When I subtract this 8 over to get y by itself, I'm left with 7y equals 0. Divide both sides by 7, y equals 0. So we have the first value there, and the step said to take this and plug it back in to this top equation where x is by itself because I want the value of x. So we're going to get negative 3 times 0 minus 2. So again, I took this 0 and plugged it in for the y. So negative 3 times 0 is 0. 0 minus 2 is negative 2. And so my answer here is negative 2, 0 as an ordered pair. Let's check to see. So I just got this value by plugging it into the top. So we're going to take negative 2 and 0 and plug it into the bottom equation here. So technically you can just type that straight into your calculator as negative 4 times negative 2 minus 5 times 0. And you want to know, does that equal 8? And when you do that, it does give you 8 because it's 8 minus 0. Or 8 minus 0 is 8. And so it does work, and so we can circle that and know that that is the correct answer. On example number 2, we have our first equation here is kind of in standard form, but that second equation has y equals 2x minus 9. And so again, I'm going to take that 2x minus 9 because y equals that value. I'm going to replace y with that. And so I have 3x plus 2, open parentheses, 2x minus 9 equals 10. And so I can tell that I'm on the right track here because everything is in x's. I don't have a combination of both. And so we're ready to simplify. Again, we're going to distribute 2 times 2 and 2 times -9. That's going to be 3x plus 4x minus 18 equals 10. 3x and 4x make 7x when we combine like terms, bring down our -18. To continue solving here, just got a two-step equation, add 18 to both sides, so 7x equals 28. Divide both sides by 7, and x equals 4. So again, we have our first variable. We're going to take it and plug it back into this equation here, where y is by itself. And that is going to help us find the value of y. So 2 times 4 minus 9 is -1. And so that's our ordered pair for -1. We want to see if it works. Okay, we're going to check our solution. We're going to plug it back into this top equation. So that would be 3 times 4 minus 2, or plus, 2 times -1. 3 times 4 is 12, plus -2 is 10. So I can circle that and know that that is the correct answer. Example 3 here, we have x by itself. And so I'm going to take it and plug it in for x in the second row here. So I like, again, to use parentheses to show where I'm going to plug everything in. So I'm going to rewrite that bottom equation as 2 times the quantity, y plus 3, and then minus y equals 5. So 2y plus 6 is what I get when I distribute. And 2y and -y combining like terms is just y. And I have a positive 6 equals 5. We can subtract 6 from both sides, and the value of y is -1. And then taking that and I'm going to plug it back into the top equation. You can plug into either, but there's less solving to do and use the top equation there. So x equals -1 plus 3. Simplifying that down, our answer is 2. So again, 2, -1 is our ordered pair. We want to check and see if it works. So 2 times 2 is 4 minus a -1 would be then 4 plus 1, which would equal 5. So I know that that equation works as well, or that ordered pair is correct. Go ahead and hit pause and attempt example number 4. And then when you're ready, we'll go through the answer. All right, so on example number 4, y was by itself, so I chose to take this -2x plus 9 and plug it in for y. And when I did that there, I was able to distribute, combine like terms, and I got x equaled 8. I took that 8 and I plugged it back in to this bottom equation, so -2 times 8 plus 9. And that gave me a value of -7. So our answer there for example 4 was 8, -7. And go ahead and hit pause and try example number 5, and then we will go through it. All right, on example number 5, we have y equals 2 plus 3x, or y equals 3x plus 2. And we're going to plug that in for the y. So when we distribute, we get x plus 4 plus 6x equals 11. So 2 times 2 and 2 times 3x. And that's okay if that in parentheses is opposite of what you have. Simplifying that down, x equals 1, and y then when you plug it back in gets 5. a lot of extra examples here for substitution. We have 3 more examples, 6, 7, and 8. If you'd like to go ahead and hit pause and try those, you are welcome to, and I'll go ahead and go through the answers here in just a moment. On example number 6, I got where x was by itself, x equals 2y minus 6. I plugged that in for x. Distributing, I got 8y minus 24 plus 6y equals 4. Combine like terms. I have 14y minus 24 equals 4, solving that through. I got y equals 2. When I take that and plug it back in to get x, I got x equals negative 2 as the solution there. On example number 7 is actually easier than any example we have done so far, but sometimes those easy ones are the ones that trick us because I gave you an answer immediately right away. It says y equals 8, and so that is already done. The only thing you have to do then is take that 8 and plug it in, and then it says 8 minus 2 equals 2x, so you have to take that 8 minus 2, which is 6, and then divide both sides by 2, so you can see that your answer is 3 for the x value. And then again, that 8 was already given to us, so we just plug it into the ordered pair. There's no work to do to get it. And then on example number 8, similar, it's a little less work. When I distribute, I just have one item to distribute to. So our final answer here on number 8 is 412. Let me know if you have any questions. I am going to go ahead and show you 2 examples here. When you get to your worksheet, you're going to have a problem where it says x equals 17 minus 4y and y equals x minus 2. There's 2 ways to do this because x and y are already solved. So you can either take this chunk for x and plug it in, or you can take what y equals and plug it in for y. Either way, this is your first step, and you're going to get the same answer no matter what. There's just a lot of different examples and different ways to start these problems. So if you have any trouble getting started, just let us know what we can do to help. The last thing to show you is what if you have an equation where it says y equals 2x plus 4 and y equals 6x plus 10. We did problems like this all the way back in the Overland Trail unit. You're just going to take that 2x plus 4 and plug it in. It looks a little different because there's no distributing. You just then need to solve. So if y equals that chunk, you just simply come down here and replace y with it. And very last thing here is if there's no coefficient in front of y, when you plug it in, there's no distributing to have to do. And so you don't even really need to put in parentheses. You just need to plug it in and combine like terms. So we're going to go ahead and stop with different scenarios there. And that concludes your notes over substitution.